Okay, good.
Question.
So we'll just do that. We'll just start. I'm just gonna go. So if you have your formula sheet, if you want to pull it out, and then maybe another piece of paper to write anything down on. We'll just kind of walk through each section and each equation, and then go from there. I don't know if I had any in here that you guys did.
I think I left mine in the lab.
I'm texting Gavin to see where he is.
I can
You have one.
grab my
Yeah.
I just keep doing it over and over.
Well, they can link it back to your email. Oh, that's cool. They're like, he's not old enough to have a child.
I mean, do random copies. I might have enough for all of you. If you guys want one of like a formula sheet you can write on. If you
Can I
want
have a
like
copy,
take
please?
notes on it.
I don't know
You're
what
good,
happened to
you're
my
good.
laminated board.
You lost your laminated
Well, I don't know. I don't. No,
To like
I
write on?
misplaced it.
I misplaced
I'll just
it.
try.
Because I never took it out of my backpack. It's just in my backpack, but I don't know where.
Is it locked?
I have it misplaced. Alright, get every note packet out from this class.
I lost the last
old
three.
note packets and stapled them together.
Do you have an extra unit 1, 2, 3 note packet?
Should've brought
I'm sure I do. They'd be in that basket.
And what did I miss?
Uh-huh.
Okay, maybe one of those out.
Yes, you can check there. They're all linked. I can send them to you too if not, if you want. Or I can print them before you leave. Okay, let's let me grab my formula sheet to look at with you. I can't have a seat wherever. Okay, so I'm starting on the front side of the formula sheet, which is the one like the heading. Okay, so the first section is atomic structure. Honestly, like these equations, you're probably going to have to use like once. That's why on the last FRQ, a lot of you didn't think of using them because we don't use them that often. But with these R4s, this is when you are primarily dealing, so I'd make a connection of this section with PES spectrums, photoelectron spectrums. Because that's normally, you're going to be given a chart of PES, which PES are the ones that are like spike thing. Ever remember those?
Yeah.
Okay, so given one of those is often when you'll use these two equations, because this is measuring energy. And so then from the energy, then they'll oftentimes have you calculate frequency, and then once you have frequency, you can calculate wavelength. C and H are both constants, right? They're defined to the right, sorry. A box of like 10 watches, and sometimes it's hard. I don't know how to turn this on. Keeps going off. Just keep pushing that. So, okay, well, I'll stop it when it goes on again. Yeah, so H and C are defined for you. One thing with all equations is always be cautious with units to make sure they match the constants. So C is in units of meters per second. So sometimes you might have to convert that to meters or something like that. So any questions that come to mind with these two equations? Another common one which happened on the last FRQ we did is they love to make you use both equations connected. So there's kind of, I'll do an orange equation that aren't on the formula sheet. Now this isn't one, I don't know, you could memorize it, but if you're not a good memorizer, you don't really need to because it's just how these two are linked together. But you can also have the equation of E equals hc over wavelength. So this is kind of how wavelength can relate to energy. So all the ones in orange, once again, aren't on your formula sheet, that you might have to use somewhere. Once again, this one you don't really have to memorize because everyone see how this comes from those two, just moving things around. So, any other questions? So for Gavin and Max, what we're doing is we're just walking through the formula sheet right now.
Okay.
And kind of just like understanding the equations better, and then any questions that come up from it, so. Any questions about that section? Okay, pretty much just make a mental note in your head that if you ever read any question that deals with frequency or wavelength or energy, come here and use one of those. Okay, next section is a big one, the equilibrium section. But honestly, the first three equations are all the same thing. Because they're all just K values, and we know this. What's the setup for a K, equilibrium K?
Products over reactants.
Products over reactants, right? So really, like, those first three, that's all they're showing you are just products over reactants, but I guess it's nice that they're there. And then the bottom ones kind of deal particularly with the acids and bases factors, in terms of like pHs. I would make a little note to myself that this equation, you don't need to know it by name, but it was the Henderson-Hasselbalch equation. So this one, I make a mental note, is the equation for buffers. Right, so any problem that deals with a calculation with buffers, that's kind of the equation you're most likely going to be using, because buffers is all about the ratio of acid to its conjugate. Yes, Zach?
What is pKa again?
Good question. So pKa is you just take the negative log of the Ka. So, is that on your formula sheet?
Yeah.
Oh, is it okay?
It's right below.
Yeah, you're good. So they'll normally give you the Ka in the problem, and then you just take the negative log of it. So, good question though. Evan?
What's the, so on that equation, the buffer one, what is the HA? Is that just the concentration of the whole, like, element, and then the A above it, is that just the acid itself?
Kind of
what?
reverse a little bit.
Okay.
So,
Like the CL.
HA is the generic way to talk about any acid, because that's why they put the hydrogen in front. And then the A minus corresponds to the conjugate base that gets made. So for example, in like the buffer lab we made a buffer with acetic acid. We had HC2H3O2. And then we added some sodium acetate to it. And so here's your buffer system. Sorry, that marker is not looking very good.
Quality marker.
Put it upside down so you can get any more out of it. And so what happens, oh my goodness, I'm gonna throw this down the hallway.
That'd be kind of fun.
Oh, I think I turned it off.
Yeah.
The little A sign is gone. That probably meant alarm, right?
Yeah. That or aardvark.
Apple.
It's
So-
the only feasible
Did you
thing.
ask that, Evan? I already forgot.
Yeah.
So this would represent HA, because it's a H with the thing, and then this is the A minus.
Okay.
You see how that links to each other?
Yeah.
Wait,
So, yeah.
can you say that again?
Yeah, so in terms of like the symbols, this is HA, because it's
Okay.
H with something, and then this is just A minus.
Okay.
You see how those are the same?
Oh, yeah.
So,
So classic.
Yeah.
any other questions on that?
No.
One thing that is important to keep in mind too is remember that the pH scale only works when you're at 25 degrees Celsius.
Facts.
If you go
Oh.
outside of 25 degrees Celsius, the scale gets shifted. Now, the only types of problems I've seen them do in terms of that are like multiple choice questions where they talk about like, there's one we had on a test I think, or maybe it's coming, I don't want to ruin the surprise. Does anyone remember a question yet? I think it's on Unit 8 test actually, maybe you just haven't looked at it yet. But there's a question that says something along the lines of that the pH of water changed when you went to 37
Oh,
degrees.
yeah.
Oh, yeah.
That one.
Does that sound familiar?
Yeah.
And then you had to explain why.
I couldn't remember how. It's just, it's broken.
And yeah, so it's the whole idea of that KW,
I don't know.
right? Because it's an equilibrium system, KW is influenced by a change in temperature, right? So, Let me look. I don't think there's any other acid-base equations that aren't on there that like I would have memorized. Any other questions in acid-base section for now that's coming to mind? Winston, can I hit play on that?
Yeah.
Okay, good.
How accurate is like the range when you have like the Ka or something and it shows like the -4 or something and it's like the range is from like the pH range is 4, like close near 4. Is that like always the case where the pH is close to that exponent?
Oh, I see. I think I remember what you're saying. So, let's go over that where we're talking about it. So, first off, so to pick an appropriate indicator, you can go off of like the, pretty much like the pKa value, which is the exponent. So like if we have Ka equals 3.2 times 10 to the negative 4, then yeah, you'd want an indicator that's around 4. Is that what you're referring to, Zach?
Yeah.
Yeah, and that once again is how you can estimate a log. And so, or I guess let me back up, not so much an indicator, I meant buffer. So that's how we pick an appropriate buffer for our system, is by going off the pKa, which is just the exponent, helps you estimate it. So that's how we pick like which buffer or which thing would make the best buffer, or if I want to buffer a system at 5, right, then this wouldn't be a good choice of buffer. So, yeah, good thing to bring up. Yeah, yeah.
So the Henderson-Hasselbalch equation, is that for like a weak acid with a strong base?
Yes.
Is there like a different one for a weak base with a strong acid?
Yeah, so there's like, it's still kind of Henderson-Hasselbalch, but it's like flipped for bases, which is interesting. It's not on your formula sheet, and I honestly haven't seen them ever use it, but it's very similar to this, but it's just everything's kind of flipped. So it is the POH equals the PKB, because you're dealing with a base, and then it's the log of the conjugate acid over the base. So there is one when you're dealing with a base buffer system that you can use, but I honestly don't know if I've ever seen it on a test.
I think I saw that equation in like one of the review videos.
Oh, they went over it?
Yeah, and I was kind of confused, like I hadn't seen it before.
Yeah, so it's just pretty much the same, right, you see the similarity of it, it's just flipped for a base system, so, yeah, good question though. Any other questions that have come to mind right now about acids or bases? Yeah,
This is like
Oh, I
kind
thought it
of a
wouldn't be right now.
refresher. How do you, recognize which one is, or which, this isn't even really about acid and bases,
you're good.
but which, substance is oxidized and reduced?
Oh, so oxidation and reduction goes down to, you have to do the oxidation numbers, and then oxidation means it's going to increase in number, and reduction means it's gonna get reduced in number.
Okay, so if it's reduced, becomes more negative?
Yes.
Okay,
And we can review those at the end if you want the rules for oxidation numbers,
yeah.
because that's a good one to definitely, like, you need to know how to do oxidation numbers, so.
Mhm.
One that's not on our formula sheet for acids and bases is the one with titrations. So the titration equation, what did I gotta say, orange is what I'm doing, is the M of A, V of A equals M of B, V of B. This is the equation for the equivalence point. Now, once again, you can decide if you want to memorize it or not. If you just understand that equivalence point means moles are equal, you can derive this equation, because that's literally what it's saying, is moles of A are going to equal moles of B. But it's an easy one because it kind of to memorize. But so if you're trying to find the concentration at the equivalence point, then you plug in what's given into there, and that will get it for you. But did I see a hand over here?
I was just wondering about the oxidation reduction, that's involved in the last year, right?
Yes.
Okay.
Yeah. Got it.
I can't remember what it is, but it was like when you had a Lewis structure or whatever of a molecule. It was like something with resonance to find the most balanced one, where you would write out like the number of bonded to the total.
Formal charge.
Yeah, what was that? The
Yes, that is a good equation to know because they love to have you do it somewhere.
yeah. What is that called again? The yeah.
Yeah, so you're pretty much what it is if you can draw multiple Lewis structures that all satisfy octets, but there's a variety of ways to do it. Mostly it's because like this one has the double bond or this one has the double bond, but it's not a case of resonating both ways. It's set one way.
Mm-hmm.
A lot of times it's honestly probably with like a triple bond.
Okay.
Where it's like I could
Yeah.
triple bond this side or I could double bond both sides. Like
Mhm.
what's it going to do? And so you calculate the formal charge of each atom to see which structure is the most stable.
Okay.
And what you want is the goal is to have a formal charge of 0 or as close to 0 as possible.
Right. Yeah.
So the equation for formal charge, do you want the book one or my interpretation of the book one?
Interpretation.
I guess I can show you both. I don't even know if I remember the book one. But to calculate the
dumb.
formal charge, you do valence electrons. Okay, so however many valence electrons something has, and I'll show you an example of it. Minus the lines minus the dots.
Ah,
Oh,
yes.
yeah.
Genius.
Sound familiar? So for example, like carbon dioxide, you technically, oh man, all my black ones are not,
Let's see it. Let's see it.
no, that was
That was
too close.
It was.
Almost.
Hit the wall.
Yeah.
Just want
How
black.
dare
I
you.
don't know why, it just seems like the right fit. Okay, so for carbon dioxide, we could draw it like this, or you could draw it like this,
Okay.
just one. Okay, where technically both of these structures satisfy octets, and you've used up all your electrons and it's all balanced, and so then formal charges can help you figure out which one is the true Lewis structure, or the most likely one. So what you do is it's by the individual atom. So oxygen has how many valence?
6.
So we're gonna do 6 minus 2 lines, minus 4 dots, so this would have a formal charge of
0.
0, yep. And then same thing you do with carbon. Carbon has
4 lines.
4 and then 4 lines, so it's at 0. And then that's obviously symmetrical, so it's at 0 as well.
Mhm.
And then, so that obviously is the correct structure.
Yeah.
Because if you come to this one, this oxygen now would have a formal charge of,
1.
yep, and then this one would have a formal charge of,
-1.
so.
Crazy.
Yeah, good reminder though, Gavin, it's been a while since we've
Yeah.
done that. So, Zach and then Landon.
What are octets again?
Octet is just the idea of how majority of atoms are stable with 8 around them. So they bond until they get 8,
Oh.
and then they stop by. So oct for the 8. So, Landon.
For the formal charge, can you explain the double bonded oxygen and carbon again? Because I'm having trouble understanding.
Like how we calculated
Yeah.
this? So you go to the periodic table and find
Yeah.
how many valence electrons it has.
Mhm.
You good there?
Mhm.
So carbon has 4 valence electrons, and so then you subtract how many lines are around the carbon.
Okay.
So we subtracted 1, 2, 3, 4.
Okay.
And then how many dots are around it as well.
Okay.
Did that answer your question?
Yes.
Yeah, Matt?
Can formal charge help you find out anything else or just that?
Not that I
You
know of,
laugh.
to be honest.
Why do you laugh at my boy Max's question?
I don't know, man.
Yeah, as far as I know, formal charge is just like, it's a book, it's kind of, I relate it really to oxidation numbers in that they're just like a bookkeeping system to like figure something out. But outside of that, I don't know if it, like, not that I know of. So,
Okay.
yeah, good question. Yeah,
Can we go over orbitals again?
like the different,
Yeah,
Like
different
the-
SP, SP squared.
Yeah, those.
Oh, hybridization?
Yeah.
Oh.
Yes,
Oh
please.
my,
There's
that's
Dude,
question.
no, it's easy, that's a breeze.
No, it's not. Do you remember like the
I do.
different
It'll be
letters,
easy
bro?
once- No, I know both
of them.
Okay, tell me what
Okay,
is
wait,
it?
so now-
What is silver, bro?
Are we talking
Silver, can I
hybridization
use
or are we
the
talking like
Gmail?
electron configuration?
No, sure, whatever. Right.
Okay, so.
Oh, yeah, because I don't know what either of those mean.
Either, I know, those were both back
Five
in unit
silver.
1, I think.
Yeah.
Unit one,
Like
like
back when you guys were just like baby chemistry students.
back
when
when
we
like
still
the
had hope
review
left.
topic thing, like all of unit one was like a 2 or a 1 for me.
I can't find silver. Can
I
find
remember
gold?
being stressed about the memorizing elements.
Yeah.
Yeah, that's so pathetic.
That
Imagine.
was what's your biggest stress.
Yeah. Like,
The
Okay,
days
so let's
of
start with
bliss
electron
and ignorance.
configurations. It's funny because they like look the same, but they're two totally different concepts. Like configuration and hybridization are similar in that they have S's and P's in them, and they're related, I guess, but
So is everything else.
so is everything else, right? Like that's how chemistry is. So an electron configuration, this is the address for all the electrons in an atom. So it tells you the placement, orbital by orbital, where all the electrons are located. Now the biggest thing is to remember that this is a map of the orbitals. Okay, so this section right here is the S section.
Mm-hmm.
This middle section is the D. This section is
oh,
P,
like-
and then this is N.
There's no way that's
But
real.
the
Wait. But
yes, except helium does belong to that empty square S.
1, 2, 3.
Wait, what are the letters again?
So S, D, P, and F.
Okay. We're gonna draw.
S, P,
Yeah,
P.
it's like a SP is like
Yeah, I just was going left to right, but. So then when you want to write an electron configuration, you identify where that element is on the table. So let's go with nickel. Okay, so what we need to do is we're identifying the location of all 28 electrons of nickel. And then think of it like a hotel or a map, starting at the top, going left to right, and just filling each orbital. So the first orbital we fill is always the 1s orbital. And so you write, so if this is for nickel, we write 1s2. So there's 2 electrons that can go in the 1s. Okay, stop me if I lose any of you. Something doesn't make sense.
The exponent is for the number of electrons.
Wait.
Let me go in.
Yeah, I'm really slow.
Yes, you're good, Evan.
What's the bottom one? The
F.
letter? Okay.
Stress don't help you. Okay, so then I went across the first row, so now I'm going to the second row. So the next orbital is the 2s.
last one.
So we're gonna put 2 in there, so we have 2s2. Now once again, read all the way left to right, so now we're coming over here. This is the, there you go, so 2p.
2P. Wait, why is it not 1P then?
What row is it on?
Aww.
Oh, the second row.
And
So there's
helium
no
is for
such
the
thing as a
first row?
1p orbital, doesn't exist.
Because it's cheating. Helium was always cheating.
Kind of think about, because the atom
It's
gets
cheating.
bigger as you go out, right? Now, once again, keep in mind if you forget, well, how do I know it fits 6? You just count 1, 2, 3, 4, 5, 6.
Facts.
Right, so it's
This
like a
one
little
I count
game.
'cause I counted 5.
It's like a little
Because if
game.
you can't count, then we might be in trouble, but. Okay, everyone good so far?
One.
So you just go on to the next row, so the next orbital would be
3S.
3s2, going across, 3p6, going down, 4s2,
Then D.
and then this is where the D is shifted down, so it goes 3d,
Ah,
and then for nickel,
why did I
we're
have to
over
do that?
8.
Wait, why is it 3 though?
Because
Wait.
it's dumb.
Why is
Why
that
couldn't they just
four?
D starts-
4?
Oh wait, never mind.
I don't get why it's 3 and not 4. It's on the 4th row.
So it's just how, so one of the rules of orbital filling, okay, is they fill from lowest energy to highest energy, okay? Now, energy is different than distance, okay? What happens here is, once again, it's really hard to, these are hard to visualize because those are not what atoms look like, right?
What
That's
are
what we
brain
make all the time.
I don't believe you.
So what happens is when you have your nucleus here, okay? So you have the 1 energy orbital, the 2 energy orbital, the 3 energy orbital. Now within this 3rd energy level are 3 suborbitals, right? The S, P, and the D. What happens is the 3D, there's not a super correct drawing, but it should hopefully
3D.
help you understand, okay? Is the 3D orbital and the 4S orbital are like right by each other.
What?
Man.
And what happens is the 4S is lower in energy, but not distance than the 3D.
What?
Because I can't draw a picture even, this is not doing a good job. And so you always fill low to high energy. So biggest thing is to remember is that this, I don't know if it helps, but like this is 3D, so it just goes 3D, 4D, 5D, 6D. It just counts down after that. But it is, you gotta be careful because it's not in line with the S's. So, yeah, Ty.
For notation, could you put argon
Yeah, that's what
in
I
like
was
brackets and then
Good.
do forest?
This man
Or-
Yeah, so the
That's
best
amazing.
way if you have to do this by hand is to do the shortcut version, which is where you take a noble gas, so the last family. Okay, so so this is correct, but the better way is to go AR, because that takes care of all of this in that little square, and then you just write what comes after. Like so.
Is that what you wrote? Is that what you wrote?
So, good for
Oh, nope.
It is actually.
Oh, dang it.
Any other questions on configurations?
Why S, P, D, and F? What-
They just decided.
Why
Super
those
duper
letters?
people. Yeah.
From what I understand, is the letter links to, and the only one I know off the top of my head, because some of them like go to like possibly like Latin words and things, but it goes to actually the actual shape of the orbital. So S-shaped orbitals are spherical, they're actually round. And once again, that's where I lose because I don't remember what the other ones, because I got P orbital.
Pyramid.
P orbitals look like this.
What?
Classic.
On
And
the
so the
side,
P has
is that
some link to that,
We all learned
I
that
don't know what it
shit
is,
in
to be honest.
kindergarten.
but that's where the weird letters come from.
Yeah,
In
You know, it's kind of about it, they just do like A, B, C, D, or something.
Oh.
Yeah, exactly. There it is.
Can we also go over the like electron orbitals where we have like the boxes with the
Oh, yeah, like from this.
yeah.
So the difference is that's just where like the 4s, so each box represents an orbital. And so the S is a single box, and then the arrows inside of it represent the electrons. So this is a visual way of showing the 4s orbital. For the D orbital, it can hold how many electrons?
10.
So how many boxes would you draw?
5. Oh,
So
you
you-
Oh, when they fill up like one by one.
There you go, yep, so you go 1, 2, 3, 4, 5, so the rule is you fill up, they all get their own bunk first,
Straight facts.
and then they start sharing, right? 5, 6, 7, 8. So, good reminder, this is what we call definition-wise as unpaired electrons. So if a question ever says like, how many unpaired electrons does oxygen have? Draw its orbital diagram, or think about its orbital diagram, and I'll show you, so.
Where did they cut off with, you got the bottom row, or the lithium and the LU and the LR, are those part of the U's or the F?
Yeah, so it's kind of weird. What does your AP one look like? I haven't looked at that periodic table in a while. So they do put a spacer block. That's what I was wondering. Some don't. This is actually one of my favorite ways to, I don't know, it's still weird. If you count across the bottom of yours, I believe there's, does that make that 15 down there?
Me during the AP test.
Man, we know nothing
My
about
decision.
chemistry.
Yeah. So, honestly, I don't know if I've ever seen them do stuff in F block. 'Cause we just don't work with those
Stupid.
elements. But the way that it fits,
They're
That's
fake
what the X-rays
elements.
are. Fake.
so LA,
Yeah, like uranium-230.
So I guess mine is like your AP one, right?
Fake.
So LU and LR are technically part of the D block in terms of the orbitals. So, yeah. Evan, then Winston.
So I just thought about this, so what if like
Hello.
you were doing a Lewis structure of something that was like in the D column, so there would be more than like
That's when the F block,
right?
Oh.
is included.
Would that be a thing or
No, because Lewis structures are only for covalent molecules, and covalent molecules are only non-metals.
Okay, I was, yeah.
Yeah, not a bad thought though. I could see where that all of a sudden would get really overwhelming, like, wait, how do I do this?
This is what it looks like when the F block is included.
There you go, yep. Yep, so that's how the periodic table should look. Now, just as a side note, electron configurations is definitely something like go back and review, because I think, I mean, it's been a while, but it's not a big part, like, of it all. So if you're, don't stress about electron configurations, right? So, Winston, what was your question?
What are the exceptions to the, like the electron configuration in the orbitals?
Yeah, so the AP curriculum states you do not have to know the exceptions, but what
We
we
have to
do
be
need to
able to explain
understand
them.
is, if given one, an explanation why. So with the
Yeah.
orbital diagrams, there's kind of some rules that promote stability, and so whatever's more stable for it is what it will do. So to create stability, orbitals like to be all the way filled
Or halfway?
or halfway filled. And so, for example, chromium does an exception where if you write its normal configuration, you would get 4s2 3d4. But its true configuration that they have found experimentally, because that's what this proves, right? So link this to configurations, because that's what this helps you determine, right? Is 4s1 3d5.
Not the same way with lead.
Oh, I remember that.
No, I don't think lead does it. Normally, it's just because the S and the D are so close. That's really where you see the exceptions happen, where they can just shift their electron over. If they're not close in space, they can't shift it over because it just would take energy to do so.
Is it only the S block that can shift the extra electron, or does it go to the other blocks
Yeah, it's
too?
really just S to D or S to F also happens.
Oh, gross, but.
Gross.
In the fire.
Grody.
What were you gonna say, Zach?
I don't know.
You're good. Evan, did you have anything else?
So like would it also happen for like copper and like that row? Like there's
Yep,
like
same thing. Yep, they would shift it and then become full in the D
in
and
half.
half in the other one. Yep, good
Okay.
observation. Cam?
We wouldn't be tested, cause I know we were doing Lewis structures and it was sometimes difficult to know how you do 5, like it was PF5, I think was one of them. We won't be tested on drawing Lewis structures for, like knowing how to draw it with
The
5.
expanded octets?
Yeah.
You could, yes.
Okay, and how do we know what, if will we always be drawing it, if there's only 2 types of atoms given, will we always be drawing, like, with one central atom?
Yes, yeah, you won't, if it's ever outside of one central atom, I've always seen it where they give you like a skeleton of where they'll like put, like I've seen one where it's like they'll give you this type thing, and then you have to complete the Lewis structure. But they won't, they wouldn't just like give you the formula, and then you have to know how to draw something like that, so. Did that answer your question?
Yeah.
Yeah, good question. But if it's like a singular one, so like I've seen one like a few years ago where you had to draw an F5, that one, because there's just one central atom, they would do that, so.
Fluorine would never be used as a central atom, right?
Good, yes. That's actually a good thing to remember too, is just kind of note, there's certain ones that can expand and certain ones that can't. Does anyone remember the dividing line?
That can what and what?
That can do more than 8 around it. like
It
when
was
you're
something with
drawing-
oxygen, cause I remember oxygen maybe. That was just the first thing that came to my
Oh
brain.
yeah.
Nope.
Was it some?
You're wrong.
I'm sure what you're-
Classic guy.
But don't worry, it's a learning
remember types?
experience. Is it fluorine?
Was it like the staircase type thing? I remember something like,
Oh. It
It's
kind of
like
falls
under
by the
that.
staircase. I never even made that connection. So it's phosphorus and above, meaning in atomic number. So phosphorus, sulfur, chlorine, argon, all the way up, those ones can expand the octets. So technically, the AP question that dealt with this was that this doesn't exist. You can draw it, but it doesn't exist.
P.
That's right.
Because
whispered like
the
No, it's
expanded
protein.
octet is all about the D shell. The D shell is what allows it to have more than 8 valence electrons. But there's no such thing as a 2D shell, and so they can't expand. So the ones on the second row don't have anywhere to expand into.
Wait, which ones can expand?
So,
Anything from phosphorus up.
Oh, cool.
yeah, so here and
Ah.
everything else.
Go.
Even uranium.
Why again is it 5 boxes for the electron configuration thing? Or you erased it, but.
Oh, because so you draw the size of it, even if it's not all filled, and so the D orbital can hold up to 10 electrons.
Oh,
So you do 5 boxes for the 10 electrons.
alright, gotcha.
So, good question.
Can we go over like, the geometry of molecular structures and like hybridization
All
stuff?
the different geometry
Yeah, and
things.
angles. nothing.
Sure.
Oh, yeah.
Sure. Any other questions on electron configurations while we're on it? Once again, I would link this to this, but that's in a sense what a PDS is. Is normally they'll give it to you and then you have to write a configuration from the spectrum, right?
So that's.
So what would that one be?
Ooh, good question. So the lowest in energy
Is the first.
is the first shell, so you always go to the highest energy and label that as the 1s. Now often these graphs are like the scale goes backwards, so a lot of times they go high to low, so this is the highest and this is the lowest. But be careful with the scale because they sometimes flip it. So the highest energy is the central orbital, so this would be 1s. What comes after 1s?
1s2.
Go into math. Oh, so this counts for both the s's.
Oh, so.
Yeah, good point though. So the height of it corresponds to how many electrons are inside of it.
Oh, right, that's
Is that ringing a bell? So then this peak would correspond to what orbital? There you go. So this would be the 2. Oh, I drew my spikes really bad. That can't make sense.
I feel like that's cheating.
Sounds like that.
Let's make it more. I was just drawing spikes without thinking.
What the flip?
Okay, let's go like that. There we go. So it should be the same size, right? So 2s,
Flip.
and then this would be 2p, and then based off its height.
It's 1.
So what element is this?
2p1 is boron.
Yep, so it'd be boron.
Wait, that's 1.
Boring moron.
I mean, my graph's not great, but I guess we're kind of looking, it's not as high as the other one, so.
Boron sounds like some lame alien from Star Trek.
Boron.
Lord Boron.
Okay,
Alright, just me.
what did you just ask?
I agree with you,
Yeah,
Gavin.
geometry and hybridization.
Oh, that actually fits perfect, because we were gonna talk about
Yeah.
hybridization. And geometry and hybridization fit.
Things are so weird.
Okay, can I erase all of this? Good.
All we do is a secret.
So what do you, like, do you want just an overview, Zach, of like the names of the different geometries?
Yeah, the names of them
It's
and
not a
like,
real secret.
the angles.
That's not a
on
secret.
the last different key, that's what they. And also hybridization. So just
Okay, so, if you have, I'm just gonna draw, would you prefer like AB molecules that are generic, or do you want like specific examples?
Specific examples.
Yeah,
Specific.
Okay.
Let's be
Pacific.
specific.
Okay,
Hey, we're on.
so if that's my molecule, you only have, so you always look at the central for geometry, right? Once again, think about our Play-Doh, like how you build these things, right? So if you have one ball in the middle, 2 balls on the outside, then that shape
That was so.
is to be a straight line, which is called
I remember that.
linear.
Remember the
and
day
has
when we
bond
made the
angle
Play-Doh
of-
things and we couldn't stop playing with the Play-Doh? It was just impossible to not.
So with the
not
hybridization
making
on that would
study
be.
going
You
on.
should leave Play-Doh on the
Yeah.
desk.
I
so
think
that
that was
we
the
could-
day of like decline.
The day of decline.
When the Empire
It has,
SP2.
two.
My brain power just
Just S.
it just don't.
Yeah, once the Play-Doh
Wait,
got taken.
So is it like that
away.
because
What?
it's no lone pairs and also it's only paired to two?
So yeah, so hybridization, you just go off the central atom's number of domains. So this has 2 domains.
Yeah.
So this is a domain, this is a domain,
Yeah.
okay? And then the number of domains corresponds to the number of orbitals you need to hybridize. So I need to hybridize an S with a P. So there's my 2 orbitals.
Could you define hybridize real quick?
Yeah.
Yeah.
Yeah, that would.
That would
I know,
help.
I hate that this is even part of the AP curriculum, because it's like,
It's not
Irrelevant.
well,
It's
no.
irrelevant.
It's just for the level they're teaching you, it's like not worth spending like the time it takes to really understand it. You know what I mean?
Okay.
But it's like, so pretty much the idea of hybridization is that when 2 atoms bond, scientists have figured out that their orbitals have to become the same in energy in order for the bond to happen. And so what happens is if you have one atom with an S and one with a P, they merge, hybridize,
It becomes-
into a new orbital called an SP. So it's this brand new type of orbital that forms when things bond.
Or
I think
Orbital.
we should take a
Orbital.
look at the hybridization question.
Run in his army of
With the
orbitals.
pi-bonds and things like
Yes.
that, and it was
Pretty sure it's
like
just
showing all the different bonds.
Yes, they're like balloon-like looking
Yeah,
things.
Orbital.
Yes.
Then we'll take Galvanic cell and die.
And then you
Come
just
by
pi-bonds.
SP squared or
Yeah.
SP cubed.
We can review that too, that kind of does geometry.
4, so like if you had 4 bonds, then.
Oh,
This is
orbitals.
This is
Join I need to switch
boron.
mine.
Okay,
Enjoy.
so if I have a 3-sided structure
Trigonal
with no lone pairs, trigonal planar, it's gonna be
The group
flat,
right here,
bond
the
angle will be,
It's like 112.
72.
120.
there you go, take a circle, cut it into thirds.
112.
No, I was thinking
Okay,
12.
Winston, what's my hybridization?
SP2.
There you go.
I
Yep.
don't know why though.
So 1, 2, 3 domains, so you need 1
Yeah,
S and 2 P orbitals.
Oh, wait a second. This all.
But like,
just makes
how do you
sense
figure
again.
out how many
What's the second
S's?
P?
Oh my. It's in space.
You only are ever allowed 1 S.
Oh.
Better.
Because if you think of a row, there's
It's
only
just
1
so-
S orbital.
Oh yeah.
That makes sense? Okay, next option is, what else do we have here?
The
Trigonal
Seesaw.
Sports.
Can't think of an example.
It's so funny how there's just the different names for these. Trigonal planar.
Oh wait, seesaw.
Boron.
Seesaw.
Yeah.
What are you
Boron.
saying?
Ben.
Okay, now in my pictures for simplicity, I'm not drawing lone pairs on the outside. Obviously, like,
Seesaw.
those are a theme, but I'm just not drawing them because they don't matter for geometry's sake. Okay, if this is my structure, I still have 1, 2, 3 domains,
Yeah, but it's different. It's not true.
but now it's bent.
What a dumb name.
And then what's my bond angle gonna be?
112.
It's less than 180.
One.
I remember 112 for some
It's
reason.
like, none of them are 112, you need to forget that number. I don't think that's ever gonna be the right answer.
No, isn't it like 106?
109.
Oh. Wait, isn't there like a point?
Yeah,
It's
0.5.
109.5.
Oh, okay. I was like,
109.5.
112.
112.
By the way, at any point, if you guys need to go, you can, but I can keep going for about 15 more minutes, so.
She can
If
go.
you need to
She
go,
can,
you can go.
she can keep going for
Get out of here.
infinite amounts of time.
It's okay.
It's okay. You didn't fail. You're just learning less.
Okay, what would my
Don't touch me,
hybridization be?
Colvin. SP. What?
SP.
It has 3, so
Oh,
it's SP2.
you're right. It is SP2. It's 4.
yeah.
Why would it be 4?
Because it has the.
You just go read.
What?
It has the
You don't know what that means.
Quick, Bond, gather the spores. We need
Trigonal
to.
pyramidal? Is that
Alright, that
what
one is now gone. One
Trigonal.
right back in.
Trigonal pyramidal?
Come on, my fellow Sporbital.
That's not this one. Do you know what this is called? Think of the
Oh no,
word
this
that
Orbital's made up a new language.
It's cursed.
you know what this is.
Orbital is cursed.
Come my sport.
In this square?
Yes. Yeah,
Name your
there you
dog
go.
Sporbital.
Yeah, so there's no such thing as hybridization.
I always remember chemistry.
Yeah, that's
My
what
dog's
it's
Sporbital.
Tetra meaning four, right? This is the 109.5.
like, when it has like this with one coming out this way and then three on the bottom like a tripod.
Uh-huh.
Which one is that? Like
Think
what?
through it. So if it looks like a tripod, you have three here. So in a
It's
sense,
that
this, that's what
What if that
tetrahedral
has a
looks
two?
like. Tetrahedral
Oh,
doesn't look
that's
like
what, that's what I was
this.
thinking was a trigonal.
Sorry, what?
So, but
Oh.
what changes between, what's the difference between a tetrahedral and a trigonal pyramidal?
Orbital.
The scariest orb of all.
Yeah, so you don't
Orb.
see, there's no spike off the top, so that's where you get your pyramid.
Orbital? Wait, I put on the
This
orbital.
bit trip.
So
This bit trip.
Yeah.
Good, yes.
Alright, we need to shut up.
The triple orbital.
Or I might just write Sporbital.
Guys,
We're
in end
for this orbital.
No, you should make for an end of year celebration, we should go to the Space Center.
I think that's fair, yeah.
What?
I don't know why, but that sounds like it'd be really fun. with
Hey,
this class.
we have an idea.
Field trip to the Space Center, is that what I just heard?
Yes.
That actually sounds
The
really fun.
Kennedy
Okay, but
Space
hear me
Center.
out. We finished AP test. We're not doing anything. It's science, because it's space.
Yeah.
And we should say funny words.
I'm sure it is. Sporbital.
If I ever become like a lead
I
engineer
don't
or
think
something,
they're like
I'm gonna
letting
name something
like,
Sporb.
go like after school. I think.
Yeah, I'm
After
down.
school.
I don't
I'm
think right
fine.
now they're doing like field trips with COVID,
We can all just.
but they are doing like, cause my brother-in-law just went last week. They are doing like, you can just like go later.
We can all just conveniently be at the
Maybe
same
it
place
Yeah.
at the same time.
Yeah, that type of thing, right?
Yeah.
Okay, what was this? So this one is your,
Trigonal plane. Trigonal pyramid.
there you go.
And then
Wait,
you
how
got
is it
yourself
trigonal,
a
not
Sporb.
trigonal? Is it trigonal? No,
It
it's
just depends on how you speak.
So it's like,
I've heard people say it trigonal, I've heard people say trigonal.
wait,
Do you need help?
no, I'm just,
Here.
I'm just happy.
You need help.
I have to do my 3D modeling in
Is
my
this one less than
mind.
109.5?
Good, yeah.
That doesn't make. Wait.
Yeah, so anytime you add a ghost, right, it pushes the bond a little bit closer.
Oh,
It's
that
like-
makes
but always
Is
sense.
it just like a little bit weaker? Like
112.
negative? Or is
Say
it
that
stronger?
again.
The ghost is slightly strong.
Yeah, the ghost has a stronger push than the bond pairs do.
So wouldn't that push it? Oh, wait, wouldn't that make it further apart? Wait. Oh,
So
for those ones, yeah.
This is, you know how we're measuring the bond to bond angle? Not the ghost, technically the ghost to bond
Oh my
angle.
gosh. Oh my
But that
god.
one's not really
Oh
a
my
bond, right, so, yeah,
And
Kenny.
why is that? Is it 'cause it can't, it doesn't have a set distance, it needs to be away from the central
Oh
atom.
my god.
Pulls them closer and forces the others away, kind of thing.
Yeah, you can think of it that way, it's kind of just fact of
Ah,
like,
you messed it
so
up.
all electrons are gonna repel, right, so these are pushing away, those are pushing away, but since the lone pairs have a bigger domain space, cause they're not being bonded and held, I guess you could say between the bonds, so they can just spread out more, and so they push on
Is it like significantly less than? You should draw just like weird looking balls with like.
Enough, I guess, that you say less than.
No.
Orbitals.
And it kind of like, the reason why we don't put a number to it is it's like dependent upon like which atoms are involved. But we just know it's gonna be less than that amount. Like I saw on there's one AP test where it had a bond angle with a lone pair and it said, hey, what's the approximate bond angle?
Approximate.
And the answer key was like, anywhere from 104 to 108 is acceptable. So,
What
Will it be
the?
tested on, or will they like have the
the other like diagrams, those Lewis diagrams where it's like the triangles and like the solid triangles and the dashed triangles.
Oh, like the 3D view.
Yeah.
What?
Honestly,
You haven't
I
played
don't
Tuber Simulator?
feel.
Sporb Simulator.
I've never seen where you have to draw it that way. They always just want you to draw Lewis structures. And then I feel like if they're giving you a picture, they just make it 3D because they can. Because that's kind of the way to draw a 3D in Tuber, right? So really, to me, the benefit of knowing that comes out actually a lot more in like organic chemistry. You use dash and bolded lines a lot. But in our level, it's more just kind of helps you see it, which is why I kind of show it to you. But in terms of you having to do it, or even them giving it to you, I don't feel like I've seen it very. I don't know if I've ever seen it. Now that I think about it. But.
There was one that.
Guys, we have to.
Do you remember seeing one once?
I mean, maybe
Oh, that
it's
makes
on a
sense too,
different
though.
test, but I saw one.
That means
The dash and then the
that means the test is 2 weeks from today, which is Friday.
Zach, did you have a question? Before we go to next year?
At least it's before the weekend.
That would also be SP3.
I'm gonna party so hard in 2 weeks from now.
Imagine
Bro,
if,
same.
what
This
if
time in 2 weeks, you'll be free.
what
Are
if
you
the
joking?
what if the
That's
AP
so true.
That's so soon.
What's this one called?
Linear.
That's called water.
Oh, that one is.
Oh, that one's bad.
Yeah, so
linear.
this
It would suck if the AP test was right after the weekend, where you weren't studying at all. You're just.
So the way I always think about geometry is I always go off domains and say, okay, well, it has 4 domains. So 4 domains is always going to make a tetrahedral shape, so your tripod with your stick, right? But now 2 of the sides are lone pairs, and so that's how you get left.
And it's also water. Water's all
And yeah,
And it's water.
so.
Water.
But still SP3 hybridization.
Is it still less than 120?
I thought it was less than less.
So now that it's become
Yes,
a
less
4
than
domain,
water.
it's based on this
Oh.
angle, and this is where we kind of did the less than.
I don't need it.
I remember in class when I said less than, and everybody's like, that's so dumb.
Oh, yeah.
And then you're right, like, that's
And that was
right.
the answer.
That was one of the greatest moments of my life.
Let's see, what's our
remember
next one?
forever.
We did 4 domains, now we gotta go to 5.
Another moment that wasn't your greatest.
Doesn't it?
112.
Wait, let's see, guys. Yep, that's real. That's real for sure.
That's a real.
It's got that expanded octet.
Yeah. Anyone remember his name?
Oh wait, I can do it. Yeah, it's by your.
Oh wait.
You got a map.
Pentagon.
I know what it
Trigonal
looks like.
bipyramidal,
There
right?
you go.
Let's go.
It's the stick with the
Oh,
threes.
Pyramidal. Pyramidal.
Because it's like the 2 ones, and then it's like
Yeah.
3.
2 3-sided pyramids stacked on top.
Guys, does anyone else have like VR, but it's real life, and you can just like model things in the air for yourself?
Yes.
You mean AR? Augmented reality?
No, it's like, I guess it is.
No, it's
kind
just
of.
your imagination.
Yeah.
Max
it.
That's actually though, Max, because that's like a huge thing in organic chemistry, is rotating giant like molecules like dopamine and bigger in 3D space. And that's why a lot of people actually really struggle with OChem is because they can't do it.
Dang.
So.
Me and Oakham.
They can't rotate.
Yeah, my organic chemistry teacher used to let
Gyrate.
us we could bring one little model, so it's just a tetrahedral, into our test. So, because it just really helped to hold something, and then like everyone's like in the test just like rotating their thing, and then
That was goofy.
we all like
Like-
named our little molecules.
Oh, yeah.
That's like something you'd see in testing to become an honorary sportman or something.
An honorary sportable.
Let's see, bond angles. What bond angles we got going on here? So this one has 2 different bond angles, right? So it has a 90. Good.
Oh my
Yep.
god.
You got 120 within the
I'm
triangle.
laughing,
Here.
I'm laughing so
Wait,
hard.
How does this one look again? Because I can't.
It's pretty much like I can't draw it on
So on the
video.
top, and then
But-
be spinning around.
Yeah.
So you have 2 sticks to trigger.
What are they called? The royal elements?
The noble guest.
The noble gases. Yes, helium, the no.
One line like
The
this.
royal element.
No, xenon would be, commands all the orbitals.
Oh.
Why is he on? It's like in the middle.
Because that's the coolest name.
Oh, Cameron found the picture.
I thought you said like multiple lines on top of it.
There you go.
Okay.
Yeah, the pyramid thing is if you kind of like were to put sides on it. Pretty much it's a diamond, right? And then hybridization doesn't exist to, at least we don't know. So, say it again. Yes. And maybe like,
What was that extra credit?
Sorry, I was laughing too hard.
What was that extra credit?
We heard extra credit and
Hold on.
Can't think of an example for our next one, but it's pretty much this, but with a little.
Hey, define extra credit.
Which one is it?
Something Winston does not get.
Taking away one of the sides. I can't think of a like real life example.
Got him good.
They try not to
So
test
good.
on her to stuff.
If you do not have,
An example on there.
Krypton.
I'm pretty sure they're.
if you do not have at least 100 smiley faces,
Okay, I'm just
you are
doing
no
80s on
longer
this
a
one.
sporbital.
But pretty much it's, you have one central, 4 bonds,
On the other side of the novel?
I'm just going to go on MS Paint and draw a sporbital.
and then one lone pair.
Whoa, does that happen?
Yep.
She's like, where have you guys been for the past 5 minutes?
So here's your original shape. One side becomes a lone pair. Cameron?
It's sulfur with 4 fluorines. Would be a
Oh, perfect, thank you. So now this is what it looks like.
Mm-hmm.
Remember its name?
Seesaw.
That's not seesaw. Seesaw was a seesaw.
Oh, that is a seesaw.
It is the T-pose.
Is it just trigonal pyramidal?
Oh, I took off the wrong side. I was like, why does this not look right? So it comes off of the circular, not the up and down,
yeah,
because the bigger
yeah.
bond angle.
So that is seesaw.
Here's
It is
the-
seesaw.
Okay, there we go.
Hey.
I was like, that's not a seesaw, but it's supposed to be a seesaw.
Let's see, it's less,
It's kind of sweet.
it's 120 and less than 90.
What is this one called?
Oh,
Ogre.
except, glad you done Devin.
That would be.
They really don't ever get less than 90.
The grade is so.
Because the repulsion, because there's repulsion going both ways, right? So this is pushing on these, but these are getting pushed by those. And 90, as far as I understand, is kind of like the equilibrium point. Like it's the most it will ever get pushed to.
It's just 90 and 120.
Yeah, so 90 and 120, yeah.
OG
The 120 would maybe get pushed a little bit more, but, so. Okay, I'm gonna erase stuff, is that okay?
Yep.
Go for it.
That
Okay,
was a
so
good
our
review
next
right
one-
there.
Oh,
Ogan Nesson.
can we review IMS?
Yes, I'll have to put it on the agenda for next time though.
Yes.
Okay.
We can that's definitely a huge one to.
We should go over that because
I like
I always
IMS.
Why is it London
IMS is one that I
Because,
just
Because
really
their forces
nailed.
Yo, did you know London had a mafia? I don't know why when I figured that out, it was so surprising to me.
London doesn't seem like a mafia.
Okay, so we're taking
Exactly.
this one, taking another side off.
T.
T-pose.
Yeah, there's your T. Now makes all of our bond angles just 90.
Yeah.
Right? And then now we get to 6-sided. So if you have one in the middle, a 6 around it, it's called a.
It's the it's square.
Square pyramidal.
No, it's not.
Octa.
Yo, wait, why are you so smart?
Hexahedral.
Do you have your notes out? Or is it just your brain? It's just his brain. Dang it.
Just his brain.
Dang it.
I remember looking on the for like one.
I know, it's kind of interesting.
And there was one with like
It's
4
because
on
they're
both
all,
sides.
because think of them as
And I
three, as
wanna
actual
know
like
what it is.
shapes, right?
If it's an actual
Um,
thing, I wanna see one.
And if you put sides on this, it's an 8-sided
It was
shape.
like, it was like,
Because it's like 2
like the
pyramid
4
diamonds
bonds,
stacked on
except it was
top of
like-
each other, right?
What does that make the
I don't know, like the octagon was like 3 on each side.
Guys, I figured it out.
this has 4 sides on each triangle.
Oh,
So, Gabe?
So there you go.
The reason he always wears a
Yeah,
hat
so if you were to like put
is
sides on
because
it.
it's one of those
visual.
hats that just is infinite and can hold as much space, and that's where his brain is.
What's our
His
bond over
brain
here?
is just too
No,
big.
no.
Everything.
No, it's because he's already
Needs
balding.
information.
It's a black hole, it's like sucking everything in.
You have the option of taking away one of the sides.
Now is it the weird pyramid, the square pyramid one?
Okay, wait.
There we go.
Square pyramidal.
And so all these that have more than the SP3,
Yeah,
that just stops. There is no SP for it.
we just don't know.
I see.
There's
After that-
something, but scientists,
I've not figured it out.
they thought they did because they taught me.
Oh, really?
When I was in college, we said that they were dehybridization. And then I became a teacher and they said, wait,
Just kidding.
we're not so sure.
It was a prank.
It is but a prank.
This is a prank.
We seriously know pretty much
You have fallen,
nothing.
you have fallen into one of the
Okay.
classic blunders.
Is there anything after square?
Oh, no, my
Oh, we
king
do
is
have,
Square planar.
yes, and then if you take away one more, the last one you get square.
Square planar.
X marks the spot.
Yeah, so-
I just love how that's gonna be on the board.
What?
That is got my sporbitals.
Have they ever seen our board?
Our board is so fun.
March
Oh.
30th.
March
I don't think anyone
30th.
else has ever, no one's ever commented on it.
What? How?
I don't know if these guys have ever seen it.
You have.
What?
I
You just
have.
don't-
It might be.
That's a
And
shame.
they
Well,
just ignore
The
it.
SP orbital.
I don't know, I've seen that, I'm like,
Orb.
Okay, but like, what about the online people?
Will you become a fellow
They can't see
sport?
it.
They don't ever
That's what
see
I'm
the-
saying.
We've been
Well,
laughing
you
about
wanna
it this
turn it
whole
around?
time.
Can I
Yo,
show them?
turn it around for these.
Okay,
guys.
any final questions on geometry before we kind of cross that off?
Wait, we should all wave so that as the camera pans
For the
past
for
us
the AP review notes, just type in sport.
to get a 10% discount from anything in the store.
Sport.
Pass off all sport merch.
Okay, listen, you might want to explain what you're showing. I don't even know. if
Hey,
that's
what's up, homies?
But-
It's our whiteboards section. That's it. Oh no, that's
Your
the
hand
camera.
just
That's
covered
the camera.
You're just so basic.
That's all it is.
Why?
All the dates of important things.
You make it sound so boring. But we have this like orbital.
We've laughed for a full 5 minutes. Gavin's
What?
getting half of
How
it.
dare you?
Well, they were
One
making
sec.
Kool-Aid one day.
I can't open this. Oh.
Oh, it's because they
Oh,
gave,
oh, oh, oh,
she
oh.
gave us all the
Everything's
Kool-Aid.
going really well.
Yeah, we drank the Kool-Aid.
Yeah, so that's why.
Stop it.
Yeah, I was like,
We're not going to
And that's what
Jonestown.
inspired it, Evan, was the Kool-Aid
Yeah.
from general chemistry. So.
Moo. Yeah, I was like, oh, this is.
Okay, you can stop it. Is it stopped?
It is
Alright.
not. No.
What?
Bye, guys.
All right.
Bye.
Say goodbye, Max.
Bye.
Goodbye, fellow sporbs.